This is one of the, I'll say, not the best, but if you have to have questions of calculating equivalent capacitance, then it's in the book, at least it's still the best. I mean, I've not done the part D yet, nor I've done the question number 27, but this seem a bit easy. And the ladder one, and the infinite ladder one, and the finite ladder ones. Uh, but if yeah, the standard questions of calculating equivalent capacitance, the best. So you have a point here. See, the bigger diagrams you make, the better, because the charge distribution is going to be a bit complex. Uh, I think I should give a bit space too, but I'll have to use two screens actually to write, since it's going to be a bit complex. And then they are these capacitors. This is 1 microfarad, 3 microfarad, 4 microfarad, 2 microfarad, again 2 microfarad. I don't know, but when I speak farad, anyways, 3 microfarad, and this is 1 microfarad. Now, what you do is that you assume a Q charge moves from here. There's a minus Q charge moving from here, and of course it's symmetrical across this vertical. And so you have the Q charge as a whole. Let's a Q1 charge be distributed over here, a Q2 charge be distributed over here. Let me get my papers, yeah. So this is Q minus Q1 minus Q2. Similarly, by symmetry, it's the negative of this. It's Q1 plus Q2 minus Q. It's again Q2 minus Q2, and it's minus Q1. So it's Q2, it's Q1. I do not know modular equations and all that. It's not mentioned in HC Verma, and I'm not doing HC Verma for preparing for J mains or advanced. I'm just clearing up my concepts. Like, I do not need to prepare for them right now. Okay, it's Q1 plus Q2 minus Q. This is the other side, the first side. Now I have to make the charge distribution for these diagonals. So uh, the opposite, it's Q minus Q1 minus Q2. It's getting blended. Q minus Q1 minus Q2, and if you add both these, you'll get Q minus 2Q1 minus Q2, and the negative of that is of course minus 2Q1 becomes plus 2Q1, minus Q2 plus becomes plus Q2. I think I should make these in a different color. I should have made the farads and the charges in a different color, but anyways, I've just realized 2Q1 plus Q2, and this is this Q, and this becomes minus Q, and so we get the opposite as Q minus 2Q1 minus Q2 minus 2Q1 minus Q2, and minus Q2 minus Q2 gets cut. So we just have its opposite, the conservation of charges. Again 2Q1 plus Q2 minus Q, and its opposite yet again Q minus 2Q1 minus Q2 Q negative, Q2 का negative, 2Q1 का negative, and let's see if the charge distribution is right. ये जो Q1 है and this Q1 gets cut, तो minus Q1 आ गया, minus Q1 और ये plus Q1 gets cut, q2 or minus q2 gets cut or minus q plus q gets cut. So it is right. It's just a bit complex. So now we are writing the equations. I will be writing the set of equations in different colors. Uh, Followed series in one color. Then after eliminating a variable, I'll use a different color. So it's like q1 bit q1 for the upper part. I'll be making 8 equations, but they're not necessary all of them. I'll still be doing that because it's not ubiquitous. Q1 is equal to C. I'll not be writing microfarads, it's just 1. Of course in the answer we'll assume it's micro somewhere. So Q1 is equal to, of course it should be micro. So Q1 is equal to C. So I've not assumed the potentials. So the potential, not green, yeah. Let me take dark blue. So V for these wires, I must say for a conducting material, the same conducting material is used to connect batteries and capacitors. There's nothing in between and it's static electricity. There's no transitional current. Then the potential will be same. So the V for the whole will be same. And for this I'll be taking this V curve. This I'll be taking lambda. And for this let me take omega. So yeah, Q1 is equal to C V minus V curve. Similarly, Q minus Q1 minus Q2 is equal to 3V. 3 and the difference is, of course it's 0. I did not write, but of course it's 0 potential. So let's continue on. For this capacitor, 2Q1 plus Q2 minus Q is equal to 4 V curve minus lambda. Oh my god. Now these two, Q2 is equal to 2 V minus lambda is equal to 2 V minus lambda. Then Q2 again is equal to again 2 lambda. Then I'll have for this 2Q1, let me write that bit later. So for these I have Q minus Q1 minus Q2. Of course I'm going in the direction of current, so positive all. The potential difference is positive, the charge is positive. Q minus Q1 minus Q2 minus Q1 minus Q2 is equal to 3 V minus omega, and we have Q1 is equal to 1 omega. It's not omega, it's omega. And then that's 2Q1 plus Q2 minus Q plus Q2 minus Q is equal to 4 lambda minus omega. So I hope all of them are right, and I got like I have to solve a system of 8 equations, so best of luck to me. Let me just verify them. 3V 2Q1 plus Q2 minus Q is 4V minus lambda. Q2 is equal to 2V minus lambda. Q2 is 2 lambda. Q minus Q1 minus Q2 is 3V minus omega. Q1 is equal to 1 omega. 2Q1 plus Q2 minus Q is equal to 4 lambda minus omega. Okay. Now I'll save a bit of steps actually. Of course Q1 is omega, so I'll use this simple fact Q1 is omega. and then replace it everywhere. So Q1 is omega. How to, like, this is eraser? No, this is eraser? No. What is eraser? How to turn on the eraser then? Oh, this is not eraser. Actually, I am not very used to my pen tablet. It's 90% is all right. Aha. Please reset, yaar. How do I turn on the eraser? Wait. Acha. Acha. Why is it skipping the eraser? Acha. This button is for eraser. This button is for, okay. Sorry. Omega. Oh, it's black. I wanted blue. So it's omega. I'm not used to it. Omega. Omega. Yeah. Now we'll use another simple file that Q2 is 2 lambda. So let's erase this. Q2 is 2 lambda. Q2, let's use pink. Q2 is 2 lambda. So let's see where do we have Q2. So here we have Q2. It's equal to 2 lambda. 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 This is equal to 2 lambda. Wait. Much better doing this. 2 omega plus 2 lambda minus q. Okay. Now we'll have to there's no way now. We'll have to solve a bit of the equation. So 2 and 2 here gets cut. So lambda is equal to v minus lambda, or 2 lambda is equal to v. Now we'll use this. Now why are we solving these equations? See, so the simple fact is we want to find a relation between v and q. Some kind of a relation between v and q. Why, you ask? Because the net, we have to find the equivalent capacitance, right? And it's the potential difference, q upon potential difference, right? We have the charge, I have started the charge q, of course. Will not be able to find exactly the charge q, because though the equations seem more than variables, some of these equations are symmetric or consistent or equal, completely same. Some of these equations, they do not look, but some of these equations will simplify to exactly the same equation. We'll get 0 is equal to 0 quite a few times. Just need to find a relation between v and q such that when we'll do q by v, we get some kind of a constant. So v is some kind of proportional to q, and we get some kq, and so after division we get 1 by k, or some kind of a constant, which is the correct answer, which is the equivalent capacitance. we need to find the relation between V and K. So in this 2 lambda is equal to V, will not replace V by 2 lambda, because we at the end we need to find a relation between capital V and Q. So I'll prefer to replace lambda everywhere by V by 2. So let's replace lambda everywhere by V by 2. So it's 2 lambda, so of course it's V only. 2 lambda is V. This 2 lambda is V. This 2 lambda, now I'm getting better. And this lambda is V by 2. This lambda is V by 2. Now I think we are left with just 5 equations now. We need to do a bit of simplification now, right? I'll just open another tab, then we'll do the simplification. Omega is equal to V minus, oh my god, omega is equal to V minus U, capital V minus cursive V, then Q minus omega minus V, Q minus omega minus V, the big one, is equal to 3 curve. Then let's simplify it orally. 4 times V by 2 is minus 2V. It comes here, it becomes 3V. 2 omega plus 3V minus Q is 4. Okay. 2 omega plus 3V minus Q is 4 cursive. Okay. Now let's simplify this orally too. 3V, okay, 3V and this V, it becomes 4V, and minus 3 omega and plus omega is minus 2 omega. So 4V plus 2 omega. Yeah, 4V plus 2 omega or minus 2 omega? 4V minus 3 omega plus 1 omega minus 2 omega. Okay, Q is equal to 4V minus 2 omega. So we already have some kind of relation between Q and V now. Just have to find this omega in Q and V, and we are done. Actually, we have this omega in Q and V. Oh, sorry, it's cursive V, so we cannot. I'm sorry. This is cursive V. Okay. Anyways, so Q is equal to 4V minus 2 omega. Then we have 2V, and it becomes just V. 2 omega becomes 3 omega. 3 omega minus Q is equal to just V. Wait. It's minus 4 omega, sorry. Minus 4 omega becomes 6 omega. 6 omega minus Q is equal to V. 6 omega minus Q is equal to V. दो और एक कट गया, एक माइनस क्यू इधर ही रह गया, एक और इधर आ गया 6, तो 6 माइनस 1 तो V. अच्छा, now okay, so we have a simple relation now. See, if you consider just these two equations, हमको Q और V में एक रिलेशन चाहिए ना, एंड बाधा ये है, ये ओमेगा. हम इस ओमेगा को इस क्यू में पुट कर दे तो हमारा क्यू वी इक्वेशन बन जाएगा. सो लेट्स वी डिड नॉट नीड टू सॉल्व ऑल दीज इक्वेशंस. कोई 0 इज इक्वल टू 0 नहीं आया. दीज इक्वेशंस आर इनफ, just these two equations. So let's just jump straight to it. Either you can multiply both by 3 and 1 by this by 3 and this by 1 and then add. I'll prefer first is equal to Q in that side. Okay, let's multiply both by 3 and then add, so that we get rid of this omega. So 12V minus Q is equal to 3Q minus 3Q plus V. Of course we are adding, so 3q plus v, and that goes there, it becomes 11v. So they're not wrong, but they're not useful too. 11v is equal to 4q, v is equal to 4 by 11q. When we are finding equivalent capacitance, of course, the potential difference between these 2 points is V, capital V. Why? You ask, it's V. The potential here we have defined it as capital V. The potential here we have defined it as 0. So V minus 0 is capital V. So if we have an equivalent capacitor, we center charge plus Q. So if there's a capacitance equivalent to all these capacitors, let's do that in the middle, it's the final countdown. Then the potential, and the potential here is equal to 4 by 11q. So this, let me erase all this. So this q and this q gets cut, and so C equivalent becomes 11 by 4. And remember, we did not include that micro thing. Yes, now I am including that. Of course, you're going to have a micro, you had microfarads, you had the capacitors of microfarads. So equivalent, when you are considering equivalent capacitance, you're not going to have capacitors, an equivalent capacitance of 1,000,000 farads. You're going to have it in micro only. So a fair guess, it's 11 by 4 microfarad. We did not include that micro. We could have, the answer will be same. We could have done that, 11 by 4 microfarad. That's it. 26A is also a bit similar. It also uses the same kind of equations. When I was solving 26A, I got how much? 1, 2, 3, 4, 5 equations. So I got 5 equations. Solving 26A. Actually, I do not know KVL and that KAL, or what you call Kirchhoff's voltage law and all that. So I have to solve them subjectively, like in this, by this long method. So that's it. So it's just, if you can solve 26B, then you can solve 26A. Okay, bye.